Hi, I'm going to go over the 2020 Algebra Achieved and Merit questions. So let's see how we go. Here's question 1. You're asked to solve first. Now this is a quadratic. The first thing you need to do is to make it equal to 0. So I'm going to shift the 10x and the plus 8 to the other side. And this is what I will get. Once we have that, it's really easy to factorize. You'll need the ACC method or another method. I prefer to use 3x and 3x divided by 3. Because 3x times 3x is 9x squared, and we've only got 3 there. And then I have a negative there, so it's plus and minus. Then I list the factors of 24 down the side. And when I got the factors of 24, it is 1 times the other to make negative 10. So I can see that 2 times negative 12 is negative 24, and 2 plus negative 12 is negative 10. So I've got plus 2 minus 12. Now I have to factorize the 3 out of this top bracket, and it will cancel with the 3 on the bottom. And so therefore we can factorize and then solve the equation. So now I can see the 3 cancels out here, and that leaves me with 3x plus 2 and x minus 4 equals 0. So putting in the values here, x would have to equal negative 2 divided by 3. Remember, we reverse the sign, divide by that, and plus 4 divided by 1. And then we've solved it. Now for the second one, we have to solve the value of the logarithm. We don't know what log base 2 of 32 equals, do we? So let's just say it equals n. So 2 to the power of n must equal 32, and that will be n equals 5, because 2 to the power of 5 is 32. You could take the log of both sides and divide, but that's good enough. That will give you another achieved mark. That will give you A4. The next one, here we've got logs. Remember, logs are powers, so the log is, or the power is 3. So there's the base. So we've got 2x plus 1 to the power of 3 equals 2x cubed plus 13x squared plus 8x plus 1. That's the starting point. Now we're going to just work on the left-hand side only. So I'm going to work on the left-hand side, and I'm going to multiply 2x plus 1 cubed. And we have to be good at doing this. You should be able to do that. We're going to use the FOIL method. I'm going to pretend that this one's not here at the moment, and I'm going to multiply 2x times 2x, 2x times 1, etc. And that will give me a value of 4x squared plus 2x plus 2x plus 1 when we multiply it out. And that's multiplied by the 1 I've crossed out. So just working on the left-hand side continued, that's 4x in the middle, so I'm going to write it 4x squared plus 4x plus 1, and we're going to multiply it by 2x plus 1. Now again, we're going to multiply each term here with another, so it's 4x squared times 2x and 4x squared times 1. So I'll do that first. So I get 8x cubed plus 4x squared. Then I do the same with the 4x, multiply by both of them. That gives me 8x squared plus 4x. And now I do it with the 1, plus 2x plus 1. And then I get the following. I get 8x cubed plus 12x squared plus 6x plus 1 equals, now what's the right-hand side? The right-hand side was 2x cubed. I'll do the right-hand side in a different color here. So 2x cubed plus 13x squared plus 8x plus 1. Now that's got from this bit up here. So I just copy that down there. Now, let's see if we can put it all to one side to make it equal 0. So I'm going to put this 2x cubed to make it minus. So 8x squared minus 2x cubed. I'm going to do this in my head. That's 6x cubed. So I've dealt with those two terms. Then I'm going to go 12x squared minus 13x squared because I'm shifting the 13. It's going to give me minus an x squared. Now I've got to go to the 8x and shift it to the other side, minus 8x. And 1 minus 1 is 0, so I get 0 there. Now I've got a, whoops, this should be minus 2, not minus 8. Common factor of x here, so I can go x bracket 6x squared minus x minus 8 equals 0. It doesn't affect the answer at all, but I accidentally copied. And I can use my calculator or the quadratic formula or factorize to find out what x is. So I've got x equals 0, negative a half, or 2/3. Now because it's a log base here, the log of 0 plus 1, log of 1, won't have any effect. Log of 0, when I put negative half, is invalid. The only one that makes sense is 2/3, so therefore x equals 2/3 is the only valid log answer, and that's for merit. So we go to the next one. We have to find the range of values for which p 3x squared plus 7x plus p has two real distinct roots. So we need to know that p squared minus 4ac has to be greater than 0. Well, what is b and a and c? A is always the number by the x squared, so a equals 3, b equals 7, and p is what c equals. So when I do b squared, I get 7 squared minus 4 times a times c greater than 0. 49 minus 12p is greater than 0. I'm going to put the 12p to the other side. 49 is greater than 12p. And then divide by 12 to get p by itself. 49 over 12 is the value of p, or you could have p is less than 49 over 12. Or how many times does it go in? P is less than 4 12s of 48, aren't they? 4 and 1 12. Yeah, whoops, 1 12, not 1 8. Here we go. So that's question 1, achieved and merit.